So we're continuing on 3.9, and it's logarithmic differentiation. But then we also want to review a little bit more about logarithmic functions. And so far in this section, we've done a lot of natural logs, but we haven't done any log base A or any base derivative of those type of logarithmic functions. And so this question is asking for f of x equal to log base A of 3x squared minus 2, find the value of A, where f prime of 1 is equal to 3. Now, how do I do this? First, I have to take the derivative. I have to find the f prime of x. And then I have to figure out, plug in 1 and then set it equal to 3. To take the f prime of x, one thing I have to figure out what's the outside function. Outside function, let's say h of x is h of u is equal to log base A of u. Derivative of outside function is basically equal to it's equal to 1 over natural log of A times u. And then if I want to if I want to find the derivative of the entire thing, I have to just use this and plug in the inside in there. So I get 1 over natural log of A times 3x squared minus 2, right? And then I have to multiply that by derivative of inside. Derivative of inside is just 6x. And multiplying multiplies by the numerator. Now, the question is asking, this was just part 1. The question is asking to do, to find where f prime of 1 is equal to 3. So if I plug in 1 in here, I get f prime of 1 is equal to 6 divided by natural log of A times 3 times 1 to the power 2 minus 2, which is just 1. And part 3 is to set that equal to 3. And then solve for A. So natural log of A is going to be equal to 2 according to this. And then A has to be equal to, what's the base? Base is e to the power 2. And that's the answer. The next question is asking to find in what intervals the function f of x equal to natural log of x divided by x is increasing, when is it decreasing, and when is it concaved up, and when is it concaved down. So the first step that we want to take is we know that increasing decreasing is just a question where f prime is positive, where f prime is negative. So the first thing that I do is I take the derivative. And when I take the derivative, it's the bottom times the low times the derivative of high minus high times derivative of low, and divided by the low to power 2. Now, the question is, one thing to remember, for this function, the domain is you cannot plug in anything negative in a natural log of x, and you cannot plug in 0, and 0 also makes the denominator 0. So the domain in here to begin with was x bigger than 0. But then now that I have found the derivative, which is 1 minus natural log of x divided by x squared. Now I have to use this derivative within the domain, which the domain of this one is also the same as the domain of the function, to find where f prime is positive, where f prime is negative. Again, this is an inequality. When it's positive, it means increasing. When it's negative, it means decreasing. So what is, and to do this, again, according to intermediate value theorem, when you're within the domain of the function, and you have to find all the points of discontinuity and all the points that makes the function 0, and then put them all on the number line, and every interval that is created by those points is going to have the same sign. That's the intermediate value theorem. Now, so I know 0 is the beginning, so everything starts here. Now, there's another point that makes the numerator 0. What is that? That's ln of x equal to 1. That is x equal to e. So e over here. Now I have two intervals, 0 to e, and then I have the other interval is e to the infinity. Plug in points for test point. Between 0 and e is 2 point something something, and so I'm putting 1. Bigger than e, let's put in e to the power 2, for example. And so these are my two test points. When I plug in 1 into the into my derivative, I get 1 minus 0 divided by 1. That is a positive value. When I plug in e to the power 2 in I get 1 minus 2 divided by 2e to the power 4, which is going to be basically a negative number. And so here we're increasing, here we are decreasing. What is that interval I'm increasing? 0 and e. The interval of decreasing is e and infinity. So see, the red is telling us about the interval. Now we have to take the second derivative to basically find the concavities of the function, and I'm trying to take the second derivative over here, and f prime of x is going to be derivative of top, which is 1 over x times x squared, and then minus top times the derivative of the bottom, 2x times 1 minus natural log of x divided by x to the power of 4. Now, if you simplify this, it's going to be, and factor an x out, then you will get an x, you will get 1 minus, and distribute this over. Let's do this. I'm factoring in x out, well, not factoring yet. Let's just multiply 1 over x times x squared, which gives me x minus 2x times, it gives me, I'm sorry, minus x. This was minus 1 over x. So minus x minus 2x plus 2x natural log of x divided by x to the 4th. Now let's clean it up, and when we clean it up, after cleaning up the function and simplifying x from top and bottom, you get this function. So the domain, and again, starts at 0, goes to infinity, I mean not including 0, and then I have to find this other point that makes the function 0, and that would be where natural log of x is equal to 3/4. That is, x is equal to e to the power 1/2, right? And then I'm putting it all on number line. starts at 0, and then I have e to the power 1.5, and then using that I have to find some test points, and test point again, 1 is a good number over here, and I see when I plug in 1 I get negative value, and here I can choose let's say e to the power 2 again, and I see if I plug in e to the power 2 I get a positive value on top, I get 1 on top, and then e to the power 3 in the bottom. So this is positive. So now this part is concave down, this one is concave up, this part is 0 and e to the power 1.5. This part is e to the power 1.5 and infinity. So these are good questions on just process of finding derivative of logarithmic function. Next, I want to discuss the implicit differentiation, where we also have some logarithmic differentiation going on at the same time. Okay, now logarithmic implicit differentiation. Look at this curve. This curve has the equation, both sides I have x and y, and I can't solve for y, and I cannot solve for x neither. And so this becomes a logarithmic implicit differentiation. Why? Because it's an implicit function. Y is an implicit function of x, and then also I have this part that is basically x to power y is making a logarithmic differentiation. And so we're trying to find the equation of the tangent line at the point 1 and 1/2. So let's just start, let's just make it to the values that we can figure out. So I'm taking the natural log of both sides first. And so it's y, and then I have x squared plus 3 to power 1/2, natural log of that, and then natural log of the other side is just y, natural log of x. And so now the next part is, of course, we want to simplify things, right? Because so that was the first step, and now I'm trying the second step is the simplification. And so the product become sum of the two, and while I'm doing, I know that natural log of this to power 1/2 comes down, and y natural log of x. Now at this point I can't simplify any further, so I take the derivative, and every time I take the derivative I remember y is an implicit function of x. I don't know what kind of function, but it's an implicit function. So when I'm taking the derivative, let's change color. And so derivative, it's 1 over y, but then I multiply it by derivative of inside, which is y prime, plus, and this one is 1/2 as the coefficient, then derivative of outside is x squared plus 3, 1 over x squared plus 3, then derivative of inside, which is 2x. Then I have a product rule on this side. Derivative of y is a function of x, is y prime, natural log of x, and then plus y times derivative of natural log of x, which is 1 over x. Now, the next step is that I want to make sure that I'm solving for y prime, right? So I have to put y prime on one side and everything else on the other side. And so what I'm ending up with is y prime natural log of x and I'm taking this to the other side, minus y prime divided by y, and then I'm bringing this one to this side, and so I have x over x squared plus 3 minus y over x, and factor y out and divide, and what you get is y prime is equal to x divided by x squared plus 3 minus y over x divided by, when you factor out y prime, you get natural log of x minus 1 over y. Now let's try to plug in the xy value in here to find the slope and then find the tangent line. Okay, now this is the derivative that we found. We plug in x equal to 1 and y equal to 1/2. And then we figure out the slope is 1/8. And the last step is to find it using this